Hi, everyone. I'm David from the Strategy Group, and welcome to Fresh Perspectives. We have Marta from the Strategy Group, and we have our guest, Zach, who are going to be talking about AI and trust architectures and the whole sort of world where those two things interact. So it's going to be a fascinating discussion. A little bit about me. So I'm David. I'm a strategy lead at the Strategy Group. I sort of come from a background of both design, technology, and human-centered design. Strategy Group, we work with all sorts of clients, and we're starting to develop the capability to do with AI, especially generative AI, but we'll unpack that a little bit more, and I'm sure Zach will talk all about where the connection between AI and the trust architecture sit. So over to you, Marta, and then we'll hear from Zach.
Hello, everyone. My name is Marta. I work for the Strategy Group as well. I've introduced myself in a previous episode, but I'm a senior strategist at the Strategy Group, and I'm managing the AI business that we are launching. And here we are for a next episode with Zach. So I'll hand it over to you, Zach, or actually I'll hand it over to you, David, for the first question, maybe. Or sorry, should we go with an introduction?
Yeah, maybe we'll start with the introduction.
We'll cut this, don't worry.
Then I'll jump to the question. How's that sound?
That's okay.
Go for it, Zach.
My name's Zachary Zeus. I'm the CEO of PyxGlobal and also the CEO of BizCubed. PyxGlobal is a firm that's building a community of trust architects and the tools that those trust architects need to solve some of the big global supply chain challenges, particularly those challenges that organizations face as they're rapidly addressing some of the ESG requirements that their customers and markets are demanding. And so we're working at sort of the intersection of policy and trade and large language models and AI and technology to help organizations really address some of the big existential issues we're facing as a society.
Amazing. Thank you. And so just for a bit of a background, myself and Zach have met a few times and had some conversations, especially in the sort of ESG space, and how you would essentially verify the types of data about certain products in agriculture, going through a supply chain, to make sure that people at the end of the supply chain can trust all the claims to do with that particular product, such as how much impact does it have in terms of the environment, in terms of sustainability and governance, which is the acronym for ESG. What's particularly interesting there is, as you talked about large language models, that's seeing probably the largest adoption of any platform over the last maybe 10 or 20 years. And so it's really making a big impact on the sort of space that we're working in, especially in technology. It's changing the sort of expectations about how people see a good service or experience delivered and how it connects with, that whole verifiable credentials and trust architecture space, which I know, Zach, you can sort of tell us a little bit more about what that means. But that's all we're quite fascinated in, especially when we're talking about how do we ensure that we're reducing bias in our interactions with AI, and how can we start to trace the authorship potentially of any sort of interaction coming from a whole variety of different artificial intelligence or generative artificial intelligence platforms. So there's a lot of questions there, but we might just kind of start breaking it down a little bit here about what these areas are and how they sort of intersect.
So I think the place to start is sort of the problem space that we're working in has been kind of prevalent for kind of the last 10 years. And there's kind of been this promise of blockchain that we put all of our data in the blockchain, do it in this sort of public distributed ledger, and magically sustainability and ESG and carbon issues will all get solved. And what we've seen in real life is that promise hasn't materialized. And it hasn't materialized for several reasons. Some was technical complexity, but the main one was commercial realities, which is if people would say, oh, put your data in my system and magically you'll get some value because all of a sudden we'll have supply chain traceability. And there wasn't sort of a direct connection to the commercial realities of primary producers or manufacturers or people at the entry level of a supply chain. And so if you don't get the traceability back to the start, you don't sort of get the value out the other side. And so we saw that kind of challenge over the last 10 years sort of manifest. There's been a lot of work and a lot of sort of pilots and POCs, but sort of the commercial drivers really weren't there. And part of that was you kind of had to get everybody in a supply chain on board in order to deliver the outcome. And everybody wouldn't go on to a platform unless there was commercial reasons to do so. So you kind of ran into a chicken and egg type problem. And the marketplace really wasn't paying a premium. I mean, there are places where you are with high-end goods and things like that, but in the main, the marketplace wasn't paying a premium. So a couple of things have shifted recently. One is the world has kind of woken up to ESG and ESG, verifying ESG claims as a means to influence the sort of carbon, the global warming issue we're all facing. And it's become pretty clear that it's existential. And so there's just this real strong shift. We're seeing boards say that they will have no scope 3 emissions by 2030 of some of the biggest companies around the world. So we're seeing significant commitments where people's necks are on the line to actually achieve these outcomes. And so what that means is there's starting to be value flowing through the supply chain to respond to that. The challenge that we see is they're only willing to pay a premium if it's verifiable. So how do you prove that, and carbon is the obvious one, but we can talk about any kind of ESG credentials. The same technique sort of applies. So how do you prove, how do you show, how do you verify that the claim I'm making about the good I'm selling to you has the carbon load that I'm claiming, or has a lower carbon load than my competitor products because of some activity that I employ? And so that the need to, so there's kind of that verification step that it needs to be added to the supply chain. And that's where we see a lot of opportunity. And then you flip it on its head, and this is where we get to some of the Web3 and blockchain learnings, is actually there's a lot of really interesting technical techniques that came out of answering the question, I've got two blockchains next to each other, how do I share data between them? And once you sort of look at those techniques, you realize, hey, you don't need the blockchain to begin with. You just need the data exchange between two systems as a general purpose solution. And the thought experiment I like people to take people on is, imagine we did get a single blockchain sort of dominating global trade. If it was an Asian chain, then Western cultures probably wouldn't use it for domestic security purposes, and vice versa, right? So if it was a Western chain, then Asian markets probably wouldn't use it as well. So as soon as you have more than one ecosystem, the important problem to solve is the exchange between those ecosystems. And once you solve the exchange between the ecosystems, then you can build the just right size system for whatever community or ecosystem that you're solving for. And so you don't have to have these big monolithic centralized ecosystems. You can have actually community-centric, right-sized ecosystems and just get really good at sharing data about them. And what we found is coming out of sort of those Web3 learnings is verifiable credentials and DID. So a little bit of technical talk, but it's about as much as I'll do on this show. Actually gives us the ability to not only share data in a robust way, but to add that verification step as well. And add that third-party verification, that's where the DIDs come in. That means that I can trust the claim that you're making at a higher and higher degree. And once you have that third-party verification, you start saying, well, you can imagine a chain of verifications, and that chain builds what we're describing as a trust graph, and that trust graph becomes really robust information about the carbon claims or the social claims or the governance claims that you might have about goods and services. And so that was kind of a very long-winded way, so I apologize for that, to sort of describe the project. What that kind of leads to, though, is a really simple data exchange format, right? So the techniques that came out of that, the Web3 experiments, actually becomes a really simple way of exchanging data. It comes trivial, and one of the things we're saying is it might be more ubiquitous than email when we think about global supply chains all exchanging data this way. And but that's the how to exchange data.
Yeah.
The hard problem is what to exchange. How do I describe the great work my community is doing? If I'm building a system or an ecosystem that describes regenerative farming or low carbon cows or high quality mining practices or regenerative mining practices or all of these things that we want to see in the world, how do I describe that in a way that the person downstream from me in the supply chain not only can trust, but understand? And that's where we see the role of trust architects playing a massive job, and trust architects leveraging large language models to accelerate that description. Because doing that on our own, it's painful, heavy, pretty technical work. Doing that with large language models, you can get there pretty fast and you can add significant value to organizations.
It's fascinating.
And that's sort of where we're working and the project we're working on. And so that leads us to kind of the next part of the conversation, I think, which is bias in AI. And because one of the things that, so that was the next question, I think.
Yeah. So definitely want to go there.
Exactly.
I think that's where Marta wanted to start to understand. And over to you, Marta. That's because there's some really interesting things there.
Yeah, I heard that you talk a lot about biases in AI, and I was keen to understand a bit more about that and maybe get a few examples as well from you.
Yeah. So there's kind of two sides to that question. And the first side of that was when we started thinking about using large language models and this generative AI techniques in advising community groups on trade, what we very quickly realized is that if we use the general purpose models, we may start, especially when we're talking about ESG type credentials, where we're trying to level the playing field. If we are using biased models, and there is bias in AI, that's a known fact. Like it's not up for debate. It exists because there's bias in society, and AI models are a reflection of society. And and that bias shows up online more than it shows up. Well, I don't know that more, but it shows up online in pretty significant ways. And so that bias exists in large language models. And so if we're using that to advise trust architects on trade, we're potentially reinforcing biased trade practices.
Right.
And that undermines trust. And so what we realized is we needed a trust architecture for the large language models that we're using to apply to trade. And that caused us to sort of go, all right, well, let's look under the covers at large language models, how they work, why they have bias, and what we can do to unpack that bias or undo that bias or protect the recommendations we're making to our trust architects from that bias. And what we realized when we started to unpack sort of how large language models work is they're also a supply chain. So when you sort of look under the covers at large language models, it takes the first question you ask, and this is where prompt engineering actually, it becomes a digital supply chain problem. When people talk, I'm going to be a good prompt engineer, what they're describing is a supply chain of interactions with different technical components to optimize the output. And because we're already working in digital exchange and supply chains, we very quickly recognized that we could apply the same techniques we're applying to trucks and packages and consignments and animals to the bits and bytes of a large language model response. And so we can, when you sort of decompose a large language model, it's a series of steps. And when a large language model goes wrong, if you've sort of instrumented the response with, this is the prompt that I provided to the black box. I don't know what ChatGPT does, but I provided this was the response I got, and I've certified that. And I sort of put that into a credential and return a key. You can sort of build up a history of all the questions and answers you received, and you can then evaluate the outputs and see where it went wrong. So it gives you the instrumentation to identify when you got false positives or responses that don't fit the outcomes you're looking for. On top of that, yeah, go ahead.
No, go ahead, please, Zach.
Yeah. So, but on top of that, we sort of also identified techniques for filtering sort of on both sides so adding some pretty sensible things to prompt engineering, which is things like, if I'm asking my large language model about topics that I haven't, that are beyond the scope of what I'm looking at. So if I'm a trust architect doing agriculture, for example, I might have a large language model that's trained specifically in the trust architecture for agriculture. And so if I ask it about the building industry or mining, it might say to me, hey, I'm sorry, I'm not trained for that. And so, and then on the other side of when it's sort of finished the response, we can have an evaluation of, does this meet my social or cultural or governance standards? So and if it doesn't, have a response saying, hey, for some reason I came up with a bad answer. Can you try again, please? And that becomes a false positive to then go research on too, right? Like, how did we get there? And then you can kind of just keep building those kinds of guardrails for the specific use case or scenario that you're working with. And then there's kind of the vector building and sort of more deeply technical stuff that sort of sits in between those two guardrails. But it gives you an idea of the kind of architecture that we're looking at to make sure that we're able to remove the inherent bias while still leveraging the amazing capabilities that sit there.
That's great. I'm trying to sort of just picture, and it's probably a future use case. One that I see at the moment, of course, and the way that people are generally interacting with, say, ChatGPT, the large language model there, is almost like a one-to-one basis. So I'd log in and ask a question, I'd create a prompt, I get a response back, and I have a history of my responses. But I think it starts to get a little bit more complicated, or we start to, include things like automated types of prompts. So that's where we're using types of, I guess, build-ons to the large language model, where the actual LLM will go and look for more details and ask you questions. So it becomes this sort of, more complex exchange. And then on top of that is when we're collaborating more. So like, for example, I might start with a prompt or get an answer, then I pass it over to Marta, say, and then you might sort of build up on that. And then there is, like what you're saying, a large chain of knowledge that goes through all these kind of steps. And it does get difficult when you, as you're saying, if we come to a certain output and it's not what we want, or there's some sort of challenge there, we want to trace back, similar to when we want to trace back a product through a supply chain where there was maybe some kind of risk, could be like a biosecurity risk. Where did that take place? So in the same way, is that what we're kind of doing as a use case?
That's exactly right. And so one of the things we realized is, if we can demonstrate trust architecture at the bits and bytes level, at the speed of bits and bytes, we certainly can do it at the speed of trust. And so it's kind of we were applying the same techniques. And actually, when you look under the covers at ChatGPT, if you sort of look at sort of the engineering articles that describe how it works, even there's a supply chain. It doesn't, when you type in a prompt, it doesn't just go straight to the large, it takes that to the first step of the large language model and tries to guess what kind of thing you're trying to do. And then it will send it down a different series of, like, they've done some prompt engineering to make ChatGPT respond the way it does already. And when we sort of think about doing more, that's that interaction between people and machines and that iterative response, we're just building up a more complex supply chain, but there are going to be mini supply chains under the covers at each tier, right? So again, building that out. And that's the same thing with product development, right? So when I get an iPhone, there's a dozen sub-assemblies that sit underneath it that come from thousands. I don't know for sure, but I bet there are 1,000 different suppliers to an iPhone, maybe 500, but it's big numbers of different components, and each of them will have ESG claims, and there will be software bill of materials that go with this. So one of the things we're looking at is, how do we know for sure that every piece of code that I deploy comes from a trusted compiler?
Right. Okay.
And becomes a big cybersecurity question. And so we're applying the same techniques, really simple sort of learnings from Web3, but really powerful when you start sort of linking them together and seeing that whole trust graph so that you go, I'm confident I can run this safely.
Yep. I think there's some key benefits there, as you're saying, to sort of be able to trace back like the source of a lot of knowledge and information. I'm just trying to think of where there may be some challenges. So for consultancies starting to investigate the use of large language models and to help sort of improve the speed of what they're doing in terms of, let's say, the research that they're doing, to help things like synthesize a whole lot of data, to do that really quickly, because usually it's a manual kind of task. And then they might sort of get that information and put it on a report to say, here's the research we did, here's the synthesis, here's some insights. So I'm thinking, maybe what we're saying is like in the future, one of those reports might have some kind of link back where you can see all the interactions of the consultant with the large language models or whoever sort of touched it. And the concern might be, because a lot of stuff under the hood is, in a sense, the organization's IP, like how they come about their insights is something that's important, which they may not find benefit in disclosing all the sort of like steps that they go through to provide that report. I just want to sort of understand that, because there is definitely a benefit to have that sort of traceability and transparency. There's also a potential concern.
Yeah, there's a number of techniques we use there. So one technique would be, rather than sort of sharing the whole. Oh, can you not hear me?
Oh yeah, we just cut off for a second.
I think it was just you.
Okay.
So there's a number of different techniques we use to address sort of the privacy and confidentiality question in building transparent supply chains. So at the sort of published report level, you may choose not to share anything. It's your prerogative, right? If there's no value to you to share the supply chain and all of that transparent information about how you achieved it, then you don't. But if it is something that is valuable to your client, you might share a hash of the set of the data of the data that was used and the whole supply chain event into your report, but you don't share the details. Or you might share a redacted version of it that says, hey, here's the last 3 steps we took. The rest of it, there's different tiers and different techniques you can use to pick what you do. And that's actually something that shows up quite a lot in commercial supply chains. I need to share that so the big one that people are talking about a lot is anti-slavery certification. So
yeah, cool.
I need to share that not only are all of my employees not slaves, but all of my suppliers' employees are not slaves, and all of their suppliers, like you need to show that all the way back in the supply chain. But I don't want to share my entire employee list. So I'm doing a $10,000 contract, right? Like that's a ridiculous burden. But I do want to share a certification that is provable. I might get audited, so I might share the certificate, not the detail, right? That's an important part of what we learned and what sort of the technical techniques that we're employing enables.
Right. Let's see. Just one last question, and then over to you, Marta. I know you had some burning questions as well. So there is a standard for HCD, an ISO standard. I don't know the number off the top of my head, but would that be an example? Like if we wanted to say, look, we're adhering to this ISO XXX number for human-centered design, we've gone through this process, and we could actually make that claim, and they could check on that to see the process that we've gone through, where we've had the ability to sort of redact certain parts or not share all the details, but at least show the process. And even potentially when you're talking about verifiable credentials, some third-party organization who is that verifier has been a part of that too. I mean, it might be a kind of like an overblown process, but maybe that they've come in and approved that we're sort of adhering to this standard. So any organizations that works with a consultancy knows that they've applied that HCD standard to the T. Is that where there could be a benefit?
Yeah. So what you're describing, the ISO standard process,
Yeah.
is often described as the conformity infrastructure for a country. So
Yeah.
the way that all works is anybody who has an ISO certification goes through a certification process. So one of my companies is ISO 27001 certified. And so we got certified by a company called Best Practice, and Best Practice is accredited by JAZANS, and JAZANS is the national accreditation body. It's part of Department of Industry. And so that pattern of accreditation and certification and certified entity and certified output is a well-established pattern of, right now, they're manually linked credentials. So the credential I have is a sticker on my door, literally. It's not very relevant in a digital world, but we imagine following that exact same pattern. And we're working with these organizations on that and one of the things we're actively looking at, collaborating with, is a continuous certification of our ISO 27001 certificate. So 27001 is the cybersecurity or the information security management certification. And so if I can continuously demonstrate compliance with that, my view is that's probably higher value than the annual certification I currently have. But there's not really a model for continuous certification yet. We're exploring that. It's one of those projects that are on my list.
Okay, thank you for all of these really interesting insights. We just have one final question, which is, so we've heard that what you're doing here is kind of integrating several technologies, right? So we're keen to understand, what have you done in the past with other technologies as well?
Yeah, I kind of hinted at that when I described sort of the blockchain, and sort of once you realize that the real opportunity is data exchange, and then once you start solving that problem really effectively, really cheaply, and really fast, then you build systems that are just the right size for the community or business or organization that you're working with. And so we work with all sorts of technologies. Like there's not a tech stack that we don't sort of actively sort of work with, because what becomes interesting for organizations is, how do you get leverage out of the massive investment that they've made over the last 50 years in in lots of different tech ecosystems, and actually getting good at exchanging data between those ecosystems becomes a really powerful way of unlocking value from that sort of that sunk cost, and potentially activating new opportunities coming out of those ecosystems. And so I mentioned I'm the CEO of two businesses. So one business is a data engineering business, and what we focus on, and that's a company called BizCubed. What we focus on is helping organizations operationalize that data ecosystem. So get their data house in order so that they can run more efficiently, do a better job, drive sort of competitive advantage through sort of just operational excellence with their data. And then the second company, and that's the one I've been primarily talking about today, is PyxGlobal, which is, assuming you have your data house in order, how do you share that data in a way that gives you competitive advantage or competitive differentiation in the marketplace? And so I kind of describe it as two sides of the same coin of data integration and systems integration. But what happens underneath the covers is we just touch every tech. There's projects we're working on that the systems are on old Windows. I think it's Windows 95 machines that and need to get off urgently. And there's sort of very modern event-based sort of serverless ecosystems that we interact with as well. So we run the gamut. What we really focus on is, how do we help organizations get really operationally efficient so that they can take advantage of those investments.
So with BizCubed, so you might help an organization, for example, like a lot of the large organizations that we work with, they would have, as you said, have legacy software and applications. They would have various arms of the organization. They would have, for example, their customers, their supplier list in different parts. They wouldn't necessarily talk to each other. Some would be on kind of, cloud-based CRMs like Salesforce. Some would just be on their own, maybe an Excel list or whatever, or some old system. And so would you be helping those organizations not necessarily create another sort of new platform that sort of rules them all, but how you kind of connect all the existing platforms to share and integrate their data so they can start to use that in a way that is reducing the manual work and the problems with kind of reconciling data. Is that right?
That's absolutely right. And really focusing on the idea of, in order to, it's kind of a Marie Kondo approach. In order to actually get efficient, you need to kind of clear the clutter.
Yeah.
And oftentimes clearing and decreasing the noise, and that gives the organization back a ton of capacity to actually create that to-be state or that significant change, or to really tackle that new market opportunity. And so we actually just come in. We don't try to rip and replace. We don't say, hey, we're going to get rid of this system. What we do is we drive the noise out of the existing systems, which gives the organization capacity to maybe actually finally get rid of the legacy they've been trying to get rid of for 5 years, or take advantage of that new market opportunity that's coming through the door, or just go to sleep on a Friday night and not have to worry about that they're going to get woken up at 3 a.m. Like we take that pain away from organizations.
I've got like one last question, if that's okay.
Sure.
I'd really love to just pick your brain in terms of where you see the future going. So and going back to AI, where do you see, for example, the key risks with AI and the large adoption of AI and generative AI, and where do you see the potential benefits? Where could like a great future go with the use of all types of AI, including generative AI?
Yeah. So the risk is we sort of outsource our individual and personal sovereignty to really the big tech vendors.
Yeah.
And the big sort of centralized system has delivered a huge amount of value for us over the last 20 years. Systems have delivered a huge amount of value. Like you look at Facebook, you look at Google, you look at Apple, you look at Amazon, they've delivered amazing things for us. And they're huge concentrations they're huge concentrations of knowledge, they're huge concentrations of commercial strength. And when I think about the risk of AI and large language models, it's the risk that those concentrations of power pose more than any individual sort of use cases. And that's not the only place, but that's one. And so the future I see and the future I want to help create is one where we're activating hundreds of thousands or millions of small communities to build the systems, the supply chains, the products, the ecosystems that really support the communities that are in those communities at the scale, at community level scale. And I think if we can leverage large language models to take the drudgery out of that, while activating our local communities, activating our neighbors, activating the musicians that live in these communities, and really create that community-centric approach, that creates kind of a nirvana state for me. And I don't know that I've quite connected sort of the trust architect role, the work we're doing around supply chains, to that future vision, but that's sort of the 3 steps forward that I see, and kind of that potential foil against kind of these dystopic sort of existential issues that I kind of see us all heading to.
It sounds amazing. Yeah. Hopefully we get a lot more trust architects to help realize the promised future, not the one where the risks and the challenges go down a certain direction that we can't sort of go backwards from. Did you have any other questions, Marta, that you'd like to bring up? Because I think it was a fascinating discussion.
Yeah. Thank you so much for this discussion. It was really incredibly and interesting. And I think we covered all the topics that we wanted to. So it was nice.
I do think we might have gone a little bit long. So I apologize. I get a little long-winded when I get excited.
No, that's a sign of passion.
Yeah, definitely. Thank you. No, it was really good.
Yeah. Thank you so much, Zach.
And thanks for coming along.
Well, thanks for having me, and looking forward to just seeing how this comes out.
Brilliant.
Okay, I'm gonna stop recording. I don't know, how do I stop recording? It doesn't. Anyways.
Yeah, that was really good. Thank you. Sorry if I was asking too many questions there. Like, I tried to follow the script, but yeah, it started to sort of go off a little bit.
That's okay. Okay. Thank you.
And we didn't even really go into sort of the why the global trends and why we think this is coming at the scale where we think, like, so the UN work and recommendation 49 and all that stuff. Like, we didn't cover some of those stuff.
Yeah, right. Yeah, I don't know how we can slip that in. So I was thinking,
Yeah, no.
we just quickly cover it now, but then be some tricky editing there. So what we're doing with this is, we've just been putting them up on LinkedIn and YouTube for now, and well, we are calling it a podcast, but it's not like published as yet to Apple or anything. But we're probably going to be doing that at some point. I think that the idea was, at least the person who's looking after our marketing, to say we'll get like a big group of, I guess, podcasts, and then when we've got a number of them, then we'll publish it on Apple Podcasts. So it doesn't look like we just got one. So it looks like there's a whole foray of them. But yeah, thanks a lot. How's everything with you, Zach?
There's a lot going on. So we kind of have 5 sort of places we're kind of focusing at the minute, and it's sort of that ISO 27001 continuous certification idea and software bill of materials are all kind of part of my sense is that's really valuable to the security